Alright, what's up APCSA students? So today what I'm going to be talking about is chapter 2 of the curriculum, which is mostly centered around primitive types and operations, so using those primitive types of data, and of course loops, which we'll talk about later in the video. So to get started, what is a data type? It's simply a name for a category of data values that are all related. So for example, again, we talked about this a little bit last video. You have things like int, short for integer, char, short for character, double, short for like decimal, I guess. And so these are all examples of data types. And then, so these are all primitive data types because they're built in, like, they're an inherent part of the Java class. When you first open up Eclipse, like, you come equipped with all of these. So something a little more advanced, although you still do come equipped with this, is the string type, which is actually something called a literal, and it's like a fixed value that's written directly into your source code. So, and it's usually things like strings. So, for example, string x is equal to hello world. And this is like an example of a string literal because it's written directly into your source code as part of the x variable of type string. But of course it can be other things as well. So it can be a decimal or a double, or it can be a Boolean value, as long as it's written directly into your source code like we've done here. And then a couple variations of integer and double, things like byte, short, and long, which are just, they take up different amounts of data in a computer's memory, and therefore they have like different limits. Like long can store really long decimals, I think up to, is it 64 places?
I'm pretty sure, yeah.
Around there, yeah. And then short, of course, like much less than that, less than a regular decimal. So you probably won't use those for now, but they're good to know. Okay, now addition in Java is pretty simple, as are other operators. It's just like basic math that you've probably learned in 3rd or 4th grade. You have addition, represented by the plus sign, subtraction, represented by the minus sign, multiplication, represented by this asterisk, so the little star, and then division represented by the slash sign. And then there is one, I guess, slightly more advanced sign in Java, known as modulo, or remainder. And so modulo is essentially what you get when you divide something and there is a remainder. So it's just the value of said remainder. So for example, if I were to do 22 modulo 10 multiplied by 2 is 20, and then we have 2 left over, so 10 modulo 2, or 22 modulo 10 would be equal to 2. So now that we know about operators, how do you use operators? Whenever an operator is used, it's in something called an expression, which is a set of operations that leads you to get a value. So more complex expressions, I suppose, would use something like an operator or a parenthesis to, like for PEMDAS, and and you can do you can make expressions with almost any kind of variable type as long as they can be added together. For example, I could make a string, and we'll call it string hello is equal to hello plus space world plus question mark, and all of these strings are added together to make string hello, and then if we were to print that out, then we'll get to see the result of our expression. So let's go ahead and do that. So as you can see here, we got hello world question mark as we wanted. And again, this is a kind of string expression. So most types, like integer or double, when you add them together, it'll just be some kind of expression. When you do this with strings, it's called string concatenation. And it's going to be extremely important when you start taking user input or making variables to hold your strings, because you can just easily join them together by doing string concatenation between variables. So, and then again, an example. So this would work just as well if I did something like this: string hello plus string question, and then if I run this, add a parenthesis, and then yeah, if we run it, we get hello world question mark. And so again, this is a kind of string concatenation, and you can see it works between variables. Moving on from there, we have different kinds of integer expressions or double expressions. And again, so you've probably learned about pentas, which again, parentheses, exponents, not so much because those are a little more complicated, but parentheses, addition, or parentheses, multiplication and division, and then addition and subtraction, and then modulo holds the same value as multiplication and division. So let's get an example of that. What if I want to print out something like the result of what happens when I divide 8 and 2? So we know the answer is 4. Let's see if the computer can get the same result as us. So I say 8, and then remember you use a slash to denote division. 8 divided by 2, let's run that, and it's equal to 4. And so now this is like the most basic kind, right? I could do this with everything. I could do 8 plus 2, 10, 8 minus 2, 6, 8 times 2, 16. And just to give you a demonstration of what modulo is, so we know that 2 times 4 is equal to 8, and then there's no remainder left over. If there's no remainder, then modulo will simply give us 0. So this should give you an idea of some of the most like basic kinds of expressions, the ones that only involve one sign between two different numbers. But I will give you like an edge case before we move on to more like complex expressions. So what if I were to do 7 divided by 2? Now you think the answer is 3.5, right? But in Java, in integer, unless you're making it interact with a double, in which case it would get promoted to a double, kind of like how a pawn can become a queen in chess. In that case, it would become a double. But here, between two integers, an integer must always stay an integer. How does Java do this? It would probably be too memory inefficient to figure out how to round the numbers, so instead all it does is it takes the 3.5, that's the result of this equation, and it just chops off the 0.5. So although this might not make much sense to you, in Java, 7 divided by 2 is 3. Unless, of course, I was to use decimals, and again, now 7.0, I've added a decimal or a double, and so then when I do division, the entire result will be promoted to a double, and so it can tell me 3.5. But if I'm just doing two integers, it'll just chop off the end, no rounding, just chopping off the decimal, and it'll tell me 3. Now, let's work on some more complex expressions. Like this would be something that would actually exercise like a little bit of your mathematical knowledge. So for example, if I said int x is equal to, and then parentheses, 50 plus 4 times 5 divided by 10. So again, this looks pretty complicated at first, maybe, but again, all we have to do is evaluate it. So using our using math and again order of operations, all we have to do is say 50 plus, so I look at the parentheses, 4 times 5, 20, and I have to do that before the addition because of order of operations. So then I have 50 plus 20, 70, and now I'm down to 70 divided by 10, 7. If we print that out, we can see that I get 7, which is again the desired result. So it can get more complex than this, but this includes like this I think is a pretty good example of what kind of expression you'll need to be able to evaluate, since it contains every single, like, I guess you could say, class of operation, like addition slash subtraction, multiplication slash division, and parentheses. And again, if you're able to evaluate this, then it's really just like taking it a step beyond and doing bigger numbers or slightly more tricky equations. But as long as you can evaluate this, like, you should be fine. So, okay, moving on from there, let's talk about division a little bit more, because this is again like a really tricky subject in Java. So division, again, we talked about earlier, when I do system.out.println 7 by 2, it only sees integers, and so it keeps it as 3. But what if I were to do something like a decimal that would go on forever? Like, for example, if I do 10.0 divided by 3.0, and again, you can see 2 doubles here, so there will be a decimal point. So then let's run that, and we can see 3.33333, and then, so there's a 5 at the end, which occurs because of a rounding error in Java. Because remember, each variable can only take up so much memory, and if it goes on forever, which it does, right, then it would take up theoretically infinite space, and you wouldn't want your computer to crash every time you had to calculate 10 over 3. And so it eventually just terminates at 5. But like, for the sake and purposes of calculations, you'll still be getting like approximately the same values, because there's like 5 at the end. It's such a small difference that it realistically won't matter. And of course, we can always use things like long later on when you've learned about those to hold bigger decimals. Aside from that, there's also, I guess now I could show you an example of just regular good old-fashioned dividing by decimals. So 0.4 divided by 0.5, and we get 0.8. So this is again like an example, right? 0.4 divided by 0.5, and we get 0.8, which again, there's like, it won't, if you've learned about things like significant figures, then you might be like dubious on this. But what Java will do, it'll always just give you the simplest possible answer, and it won't bother with anything like extra zeros or anything like that. So in that sense, it's quite like simplistic. Furthermore, we also have, I guess, like, one more time, a final edge case is, what if I have to divide decimals and integers? So I showed you earlier with the 7.0 divided by 2, the expression will simplify to decimal, and again, it does not matter if it's on the top or bottom. For example, I could do 7 divided by 2.0, and just because of the mere presence of a decimal or a double, the entire thing will get promoted to a double, and so it evaluates to 3.5. Yeah, and so that just about covers like operations and order of operations. And then again, one more thing you want to do, you should remember this, is just like in real math, dividing by 0 is never going to go well for you. If I do 7 divided by 0, I will get, there's a specific kind of error, division by 0, and of course, because that gives you undefined, which the computer doesn't really know how to tell you, right? And you can't like trick it by saying int x is equal to 0 and then doing 7 divided by x. It'll like, because of course x is just 0, right? And the computer sees that, and it's division by 0, so you can't do that. Now then, there's a lot of fancy terms in APCS that aren't always required to know, but many teachers will require you to know like vocabulary on the test so that you can, not on the AP test, but on in-class exams, so that you know like terminology used by programmers in real life. So, in terms of the, I suppose, like in terms of terminology, so plus and minus are called, they're called unary operators, which is spelled like this. Or like more, if you just wanted, again, unary operators is plus and minus, but you could also just call them additive operators, which in my opinion is much simpler. And then for the rest of our operations, modulo, multiplication, and division, those are called multiplicative operators. And now, so, and then again, we've already talked about the modulo operator, and you might be wondering, like, what are the practical applications of this? When would I ever need to use this? But in truth, it actually, and especially in APCS with the projects and all that, it comes up a lot more than you might think. Like, for example, say I want to have something happen, like I want to check what something is divisible by. For example, say I'm writing a program to check if the number of apples on a tree are divisible by 3. So I would have my variable apples, and apples is equal to 72. And then I don't want to do the math myself, right? Especially if it was a bigger number, like let's call it 72981. And I don't want to check if that's divisible by 3. So all I have to do is system.out.println apples modulo 3. And if I get 0, then I know it is. And I get 0. And so now that I know, oh, apples is divisible by 3, and this allows like my program to work as intended.
And then a lot of programmers also use this function to find out if numbers are even or not. Basically, you can just take the modulo by 2, and if there's any remainder, then you know if it's even or odd.
Yeah, because when you divide by 2, your modulo is either 0 or 1, depending on whether it's even or odd. Okay, and then finally, one more thing to do with expressions, and this is actually surprisingly useful in a lot of cases, is the process of casting, or specifically typecasting, which is where, so casting is defined as the explicit conversion from one value type to another. And again, but you could see it like this. If I were to call, so say I had double number is equal to 99. So this is a problem, right? Or rather, it would be if I said that int number is equal to 99.0. But so this is how casting works. It's almost like another kind of multiplication, where you're multiplying by the int value to turn the entire thing into an int. So obviously an integer can never have a decimal value, but with casting, it converts this entire expression into an integer, and so it would just be 99. And then again, we can see that if I print it out, number and now let's run our program, and it's just 99. So int can be used to like terminate this. And again, it doesn't seem that useful, but what if I want to, like, because I'm just doing it on a very simple example, right? But let's go back to my 7x2 example. What if I'm just trying to find, so there's something called the floor function, you might have heard of it, and it's like rounded it all. When you're given a number and you take the floor function of it, then it rounds it down to the nearest integer, no matter whether in normal rounding rules it would be up or down. So if I was trying to program something like that for myself, then casting is a way to like make me avoid having to use more complicated methods. I can say int number is equal to int 7 over 2. And it says 3, because again, it'll never round up. It always just chops the decimal off, and that's rounding down. And then another piece of terminology you might want to know is evaluation, this is just the process of obtaining your expression value. So again, every single time I calculated, or the computer calculated the value of an expression, that was just it doing its evaluation. All right, and then, okay, so this just about covers everything you'll need to know in terms of basic data types, or at least the ones you'll be using for now, and how to add and use them with expressions, and how to evaluate them, how to make the computer evaluate them. So again, you might be like wondering, because especially you might have seen that programming can get math heavy if you're using an algorithm to determine something. Like you might have to do squares or cube roots and things like that. And again, there's a built-in class called the math class, which is something that we can use to evaluate those. So we'll make a separate video about that, but all you need to know about it for now is that it exists and it can be used to like simplify math significantly inside Java. So the other topic that we'll be covering in this video is iterative loops, otherwise or better known in this chapter as for loops, which for loops are amazing for a variety of different reasons. It's just that they can help simplify like the process of doing something repetitive. So like for example, if I wanted to print out like hello to different people, or say I wanted to say hello Sam 10,000 times, I really want to get his attention, right? Now one way to do that is system.out.println, and then I could say hello Sam, and I could do this several times. I could print this out again to make it up to 2, or even faster, I could just start copy pasting. But even then, how would I do it 10,000 times? Like that's just a lot to keep track of. A much easier way is to automate the process using for loops. So how do I make a for loop, you ask? The basic syntax of any for loop will look like this. For, so you start with for, and then for, and then usually in for loops, you'll have like a variable that's kind of created inside these parentheses, usually called int I. And so what this int is, it's like called, and of course you can call it anything you want. I could call it int counter or int x, but it's usually just called int I for like simplicity inside the loop. And what it's used as is it's used as a counter to keep track of the of like where you are in your loop. So I'll show you an example right now. I'll have it start out at 0. I'll have it and then now, so the first part of any for loop is creating like the counter variable, right? And then I put a semicolon to indicate I'm moving on to the next section, which is like the condition. How long do I go on for? Now I want to make a multiplication table of things, let's say of the number 2 all the way from 0 through 10. So I'll say I, which remember starts at 0. I is less than or equal to. This is important. So look at these. What you can see here is that I used the less than sign. And then in Java, there's no way to represent like the less than with the underscore under it. You just say less than and then equal to indicate, again, that my value has to be less than or equal to this. So this is the conditional part, right? And I say I is less than or equal to 10. And then finally at the end, I plus plus. So this is just like a simple kind of operator to show that I'm increasing it by 1. And if I wanted to have it increase by 2, for whatever reason, I would say I is plus equal to 2. It doesn't really make a difference. But again, this is the most common kind of for loop you'll see. Again, with like this number being variable, right? And then just a quick, so again, and then going back to variables really quickly. So you might have seen before, when I'm increasing variables, one way to do it is int x is equal to x plus 10, right? And then let's define int x up here. And so then when I have, and then I guess I would just say x is equal to x plus 10, right? And now x would be 11, of course, but this can often take a lot of time. So again, one thing you learn about programmers is that they like to do things the most efficient way. And the most efficient way in Java is a simple statement that goes like this: x plus equal, and then whatever number I want, 10. And then of course add with the semicolon, end with the semicolon. And now so far my value has gone up. So right here it's 11. And now I'm just adding 10 to it again. And now it should be 21. So to test that theory, system.out.println x, I'll run it, and then if I do run it, then I see 21. So, and you can do this with any operator. You could even do modulo equals 10, and that should give you, what do you think that would give you? If I have 11 and I'm doing modulo, because remember I haven't added 10 to it yet, so right now it's just 11. So if I do 11 modulo equals to 10, it's going to make it equal the remainder when divided by 10. So if you think the answer is 1, then you would be correct. And similarly, x minus equal to 10, it will go back to 1. And even x times equal to 10, 110. And then, I think you should get the idea with division as well. You might think, again, don't think it's going to be 1.1, because I don't see a decimal here. And that means that it's going to cut off the 1.1 that it should be and just turn it to 1. And so this is how those operators are used to simplify the process of updating variables. And so another thing is, and then now going back to for loops, now that I can see I've got like all of my stuff set up, right? I can see that I have my conditional, my counter variable, and increment, which just means like the increase at the very end. So this sets up a for loop. Then I put one curly brace right outside, and then another curly brace right here to end that, to mark that like this. So everything inside these two curly braces, those are what is going to be like in the for loop. So now, if you remember, I wanted to make a multiplication table of the number 2. So here's what I do: system.out.println 2 multiplied by, and then if I did multiplied by 1, then multiplied by 2 and so on, right? That won't help me with anything, because in that case I would just still have to do all the print statements myself, and then the for loop would just cause it to happen 11 times. Instead, what I do is system.out.println 2 multiplied by I. So then when I do this, you can see 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All of the variables, or all of the multiples of 2 from 0 through 2 times 10. So like, this is a pretty small example, but if you want to see it on a larger scale, and I can make this number quite big. So if I said 200, for example, you'd have to scroll all the way up to see all the values, but I think you can clearly see every single multiple of 2 from 0 through 400. So just like that. Because imagine if I was printing this out. Not only would this have taken me a ton of time, because I would have to keep changing the variables, it would have taken over 400 lines of code. And here I was able to do it in 3. So again, I think you can understand now why for loops are so important for efficiency, because in terms of how you've been doing things so far, if you want to print out or do lots of addition or anything like that, it's going to be really complicated. With this, it's like done in the blink of an eye. So what are some other ways you could use a for loop? Right now, I've used it to show me a multiplication table, but there doesn't have to be a print statement inside a for loop. Let's go back to my example with int x. So I have int x is equal to 1. And what if I want to, let's say int x is equal to 0. What if I want x to be the sum of all numbers between 1 and 10, which I guess, and then of course we'll change I to 1 because, and you'll see why in a moment. And now what I do is x is equal to x, or I guess x is plus equal to, using the operator we learned earlier, x plus equal I. And every time I increments, it'll get added to the updated value of x. And so it'll keep increasing, and x will keep storing the increased value until you get your sum of 10. Because if I were to show this step by step, then it would go something like this. So on the first trial, I is equal to 1, correct? Or x is equal to 0 and I is equal to 1. I add x to I, and remember, now x is saved as x is equal to x plus I, or x is saved as 0 plus 1. So on my first trial, at the end, x is equal to 1. On the next try, I goes up to 2 and x is still 1. So now it's 1 plus 2, 3, and so on, right? And then instead of typing it all out myself, I'll use a print statement to show you the process. So I'll have it print out x along every step of the way. Now let's run our code. And what do we see? On the first step, I'm adding 1. On the second step, I'm adding 2. On the third step, I'm adding 3, and so on, all the way to the last step where 45 goes to 55. And I can see, oh look, I just added 10. So if any of you have learned about sigma notation in math, or like how to sum a bunch of numbers, this is a really easy way to do it if like there's such a noticeable pattern. All right, so this is the basic kind of for loop. Again, like some examples I showed you, summation, printing out lots of stuff. And now a little more advanced, or I guess complicated way to use it is a for loop inside a for loop. So it's the same syntax though. I could say, and I can't say I, because again, one thing about variables, you can't have variables with duplicate names. So I can't have like int I and int I. So I'll say int j, which again, this is the most common because alphabetical order. Int j is equal to 1 as well. And I want j to be less than or equal to 10. And oh yeah, and then I'll have j plus plus, and then end it with my 2 curly braces. Now, what are some applications of what I could do here? Well, I could print out I times j if I wanted to show that. So what would be the advantage of showing out I times j? Probably that I could show you like every single, I guess, multiplication value possible if I were to multiply numbers between 1 and 10. And again, this seems like it doesn't seem super useful immediately, but like in programming, you'll be asked to do a lot of weird tasks for like not always the clearest reasons. But again, if you see things like this, then like they're not as uncommon as you might think. In programming, any task will have like at least some kind of meaning to it. So these are nested for loops, and again, they work just like for loops, but they'll run more times because, so I think all of you watching this could tell me how many times my first for loop would run. If I is equal to 1 and I is less than equal to 10, there's 10 numbers I can be, and so this would run 10 times. But J would also run 10 times, you might think. If so, then that would be incorrect. J would run 100 times because it runs 10 times each time I goes through one iteration, which is like what you call a cycle of, or like what you call one run of a for loop. So the first for loop with I in it has 10 iterations, and J also has 10 iterations for each iteration of I. So 10 multiplied by 10, 100. One more thing you'll want to observe is that variables like I that are created inside for loops, I believe they're called local variables. And the thing about these local variables that makes them special is that if I try to make int I outside of this for loop, say like 908 is equal to, int I is equal to 908, and it's not giving me an error, even though when I tried to do it in here and make int I, it was giving me an error. Why is this? Because there's something called scope, which again, like we'll make a video for a lot of these like fringe terminologies later. Although scope is pretty useful because essentially what scope is, it's like the range of where a variable exists. If I made int x up here, then x would exist all throughout the main method. If I were to make another method, something we'll cover later, then x would not exist in that method unless we did something special to make sure it did. Same thing with I only exists within the scope of these two curly braces within this for loop, and therefore we can have I outside of the for loop, and this is just like a way to show the local variables of the for loop. Remember, so because again, I don't want to have to make like I1, I2, I3. And especially with good variable names like counter, if I wanted to make them outside the for loop, I can still do that. And again, if I were to make another for loop, I could still call it, I could still go with that same kind of syntax, right? For example, let's change this back to I. And then if I have for int I is equal to 5,000, I is less than equal to 6,000, then I++, and it's not giving me any errors. I can make another I, and again, like the one that came before it, this I will only exist inside these small for loops, within the scope of those for loops. And then I guess one quick way, so what if I wanted to do counting down? Then it's quite simple, really. I just have to do I is less than equal to something instead. I is greater than equal to something, which is like the opposite of what we were doing before, right? Say I want to do a 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 countdown. So I is equal to 10, and I is greater than or equal to 1. And then I minus minus, which remember from earlier, is the same thing as I minus equal 1. And then if I were to print out I, then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and everything before it is from our first for loop. Now, one really cool thing, my partner, I want to show you is, I guess, one really creative and fun way to use for loop. So there's something called ASCII art in Java. So Michael, would you care to explain what ASCII art is?
Basically, it's like a text representation of art using only alphanumeric characters.
Exactly. And so like some examples, cats, or as what we're about to show you, a rocket ship. So let's scroll up to the top. So it's called draw rocket. We'll want to change that to program, because the class should always main, sorry, because we'll always want to have it match up with.
And for those of you who are wondering, this is a project we made in our APCS class in previous years, and we're showing off like how you can draw ASCII art with these nested for loops.
Yeah, sorry. So I figured out that should be called program one because as you can see, I'm working in a file called program one, and therefore the class needs to match up with the file name. And as you can see, like, note the excellent documentation throughout. It's not always necessary to have this much documentation, but again, to someone else reading your code, it really helps them like understand without having to try to like work through all your logic. Cause like, just like skim through this 5, 4, 3, 2, 1. And like I don't think you got any of that, right? And that's not your fault because again, I didn't give you much time, and also because it's just hard to understand immediately. But if you can read comments, it becomes a lot faster. And so now let's run it, and I'll need to increase the size of my console a bit for this. But if we run it, we can see that it makes a small rocket ship. And so one thing he's done is make it like dynamic, which is when you can change the size and then the rocket ship will get bigger or smaller. So now I'll make size 7, and as you can see, like my rocket ship is a lot bigger. And this is just like the very base of ASCII art. I've made smiley faces, or well, my partner has anyway, and people have made like cats and just drawings of real people with ASCII art. So all right, that's about it for content. Now again, I'd just like to go over a quick final thing about what to do exactly to practice this. So it appears that Practice It has fixed some of the issues they were having last time, so you can create your account there. Because again, like, I might just be a little biased, but Practice It is a really great way to practice, especially early on when the exercises are like simpler and don't take a really long time to complete. But again, there's also their code step-by-step, which again, like, this also has plenty of excellent exercises for every single language. So you can see loops down here, that's one thing. And then there's definitely one for expressions. So if I wanted to do expressions, then I could, like here, what Java expression produces the second to last digit of the number, and then like hint, that's modulo 10, which would give you again the so. And okay, that's it for practice. Now, one thing again, as an APCSA student, it can be hard to get good feedback, although of course your teacher is a source, but it's good to have multiple sources of feedback. And so again, if you ever would like any help or feedback on a project, feel free to send it to us over, or post a link in the comments, send it to us via like posted email.
And we'll also have our email linked in the description.
Exactly. And so if you would like to see any problems or I guess good things you've done in your project, all you have to do is send it. Yeah. And thank you for watching. Bye.